Right, okay, so this video is going to be very different to what I usually do. I'm going to talk through this piece of software here, which is called Grid Algebra, and it's something that I've used for the past month or two, and I think is just really good for teaching algebra to younger year groups. I've been teaching for a few years now, but never really had the chance to try this out because I never really have had a younger year group that I taught all the time that I could use it on. I will say a bunch of things first before I start talking about it, though. I mean, again, I've only done it once all the way through, one time really, with a couple of different classes in that one time. So there are people much more qualified to talk about this than I am, including these people, Jay Winfield. Dave Hewitt is the person who invented this software with the Association of Mathematics, and Tom Frankholm is the person who taught me to be a teacher and showed me this thing, which I've only used a few years later again because I didn't really have a class to do it with before. All these people are obviously much better at this than I am, but anyway, I'm the one who makes videos, so I thought I would talk about it. Also, though, I would say before I start, there are resources in here. By the way, to find grid algebra, you literally Google grid algebra, and it's the first thing that comes up. There are resources in here that they have that you can download that are really helpful. But essentially what I'm going to do is I'm going to talk through how I used it and the way that I did that I think worked quite well. In the description, I'm going to put this entire PowerPoint in so you can click on it and you can see all the stuff that I used. And I'll just talk about what I did and how it worked quite well for me. Okay, so what is the grid then? What is grid algebra? I called this the grid with my classes because it sounded quite cool. So we had on the grid lessons and off the grid lessons, which they quite liked. What we do to start with is that we just show them the grid by clicking this fill in numbers thing. And you ask them to talk about it and like, what is it? And they'll just say it's the times tables, and that's good. It is the times tables kind of, except it's a cool times table because you're allowed to get rid of the numbers and you're allowed to kind of shift the times table along. So if for example, I put a 9 here, then the times table will start with the 9s and then the 10s and then the 11s and 12s and 13s and so on. And you talk about this a little bit and you get rid of all the numbers again by clicking this and then this. And then you go, okay, well, what if I just put a random number in here somewhere? What number is this? You can use these fun coloring things. What number is this? And what number is this? And what number is this? And what number is this? You can go much slower, of course, than this. But hopefully, if you've talked a little bit about the grid and how it worked, they'll recognize that this is the 10 times table, so this must be 30. This is the 9 times table, because it's 1 to the left, so that must be 18. This is the 11, the 12, so 24, and then whatever this is. And they can start filling this in. You can do lots of mini whiteboards here, or lots of cold calling if you prefer doing that. And you can just do lots of this out loud. And you can just practice getting all these numbers in here. And you can mark it, of course, by putting all the numbers in by clicking this button, and you find all the numbers and so on. And you can just do lots and lots of that. And so that's kind of phase one, is just using grid algebra to fill in the numbers. And what you're aiming for is to really get this idea to them, that dividing you go upwards, adding you go right, taking away you go left, multiplying you go down. So as I said, the times table is going down, you can of course divide to go up, left is taking away, right is adding. And what you want them to notice is that as they kind of fill in these numbers here, and by the way, when you give them sheets like this, so I just gave them sheets that looked a bit like this here, you can get them to fill in all the numbers if you want to, or you can just get them to fill in the highlighted ones. I got them to fill in all of them and then just said, okay, we'll mark using the highlighted ones, so I'll call out the highlighted numbers and that's how we'll mark it. And they bought that, so they filled them all in happily, and then we marked using the highlighted. Or you can just get them to fill in the highlighted because you want them to work out in their heads. You want them to jump a little bit along and not do the whole thing. It's kind of up to you. It might depend on your ability group, of course, but I've got lots of these. Of course, you can start with numbers up here, so they have to divide first. What you want them to notice is getting to the top row is super helpful because then they can just think about times tables. Like this is the 20, this is 21 here, so this is the 20 times table, write that down. This is the 22 times table, put that down, and so on. That's kind of how you want them to work it out. But you also want them to notice tricks, right? Like, for example, working out the 22 times table, which is what this is, might be, they probably don't know the 22 times table, so it might be easier to notice that this one is just going to be 42 plus 2, right? You add 1 when you're going across the top row, but you add 2 in the second row, and 3 in the third row, and 4 in the fourth row, and 5 in the fifth row, and so on. And that's probably easier to know than doing the times tables for numbers that they don't know the times tables for. And noticing that is really important and really useful because in phase 2, and you can give them as much practice of that thing as you want, by the way, like year 7s, which is kind of what this is probably targeted to, will love just filling in the numbers because that's just, they can show off their primary school maths and they like filling in stuff and they like doing numbers. So they'll happily do that. But phase two is kind of a little bit more advanced. What you want them to notice is that, okay, so when you're doing grid algebra, by the way, if I put like an 8 here and I ask what's this number here, if someone says 7 because they haven't recognized that left is taking away, not up, if you try and put 7 here, the grid won't like it. It'll be red. It won't let you put 7 here. It will only accept a 4 here. Right, so when you're cold calling this, you can point that out. But also, what you also want to point out is that the grid doesn't actually like calling this 5. Like, it will accept 5 here, and you can say this to them. It will accept 5. It will put it there, but the grid doesn't like it. What the grid likes is the grid likes to call it 4 plus 1, and it doesn't like to call this 3. It likes to call it 4 minus 1, and this one is not 6. It's 4 plus 2, right, and then 4 plus 3. And when you're going downwards, again, so this is 4, 8, 12, 16. This here, though, so this is 4, 5, 10, right? And your kids will say, oh, this is 10. It's 4, 5, then 10. But actually, what the grid will do is it will call it that. It will say it's 2 lots of 4 plus 1. And this is some new notation for them to look at. But you just look at it and you go, okay, well, this is what it's doing every single time. For this one, this is the odd one out. It's doing this, and you'll explain this a bit more in a second. But it likes these brackets, right? This is how it expresses it. This is the 3 times table, so it's expressing it with 3 brackets, then 4 brackets, and so on. And you look at this quite a bit, and again, you can do lots of cold calling. You can do lots of mini whiteboards. You can, of course, clear everything. You can do the same thing we did the first time, where you put a number down and you say, okay, what would the grid call this? And they'll go, okay, well, 5. Oh, so this is 10. No, the grid would call it 6 minus 1 is here. Oh, sorry, I'm still coloring in. 6 minus 1 is here, and then 2 lots of 6 minus 1. Right? So you want them to start saying this idea. Is 2 brackets, 6 minus 1 brackets is what I got them to say. And likewise, you also have to teach what it looks like to go upwards. So if I clear this, by now they should know division is going upwards because they filled in all the numbers. This one here looks like this. Right, that's how grid likes to do division, 8 over 2, and then 8 over 2 minus 1 if you're going 1 to the left. And again, you can get out some colors, you can do some mini whiteboards, you can ask them what different things look like. And then, of course, for the rest of the lesson, you can get them to fill them in. Right? So this would be 6 minus 2, this would be 6 plus 1, and so on. You can start off with these easy ones. You can do some more complicated ones. I haven't got the answers to all of these, but that's okay. And again, spend as long as you like just getting them to fill in these sorts of things and recognizing how grid likes to write these things. For this one here, this case here, I allowed them to write 2 brackets 16. I just thought that was something that they could do if they wanted to. But again, we'll explain why grid does this differently here. This is completely wrong, isn't it? Is it? Oh no, okay. If you're doing 16 times 2 plus 4, or it would be 16 plus 2 brackets 2, 16 plus 2. We'll talk about that later, of course. Okay, so you get them to fill in lots of these, and then the next step, and actually maybe this step is, this is some extension, by the way, if you start with something that isn't an initial number. Next step is to follow paths with these things. So you can do something quite cool here, which is you can call a box a number, say 5, and then this chain function is quite nice. You start at 5, and you can get them to give you a chain of expressions, right? So if 1 is 5, and the way that I got them to write it down on their mini whiteboards was say 1.5, or in this case 1.18, or 1 bracket 18. And then they tell me what's underneath button number 2, which will be 18 minus 1. And then button number 3, 3 brackets 18 minus 1, and so on. And again, you can do so much of this with mini whiteboards, right? Because you can just super quickly, like look how quick this is, as they're rubbing off their last attempt, you plop an 8 down there, tell them to write down 1.8, and then you give them a new chain to do. Like, I've done entire lessons which were just this, just me doing hundreds of those, them writing down the chain with their mini whiteboards. And then, of course, once you're happy they can do it, you can finally give them some independent work to do on that same idea, right? So 1.18, 2.18 minus 2, 3 dot is 2 brackets 18 minus 2, isn't it? And they can do all that. You can do much more complicated ones. And of course, what you want them to notice, particularly with these more complicated ones, is that when they write these chains, here it is, you start repeating. You want them to notice that you repeat things over and over again. 18 plus 3. Then the 18 plus 3 comes here with the 4 brackets. Then 4 brackets 18 plus 3, then you do something else. Then 4 brackets 18 plus 3 minus 8, then you do the next thing. Right? You keep repeating over and over again the things that you've written down. And that's kind of what you want them to notice. And you've got an entire another lesson. These, by the way, the answers to this, I think. You've got an entire another lesson to do this. Also, look how complicated you can make this. Like, the kids pick this up really quickly after you build it up, after you give them some easier ones. kids will pick this up and start being able to do stuff like this. Anyway, of course, once you've done that, you can start using algebra. So the next lesson I start, by the way, I call these phases, not lessons, because some lessons will take more than one, or some phases will take more than one lesson. So you're just moving on to the next thing and the next thing whenever the kids are ready. But of course, the next thing is you just put a letter down. So in grid algebra, instead of putting a number down, if I delete all this, no, I don't want to do that. If you delete all this, you don't have to put numbers in here. You can grab this letter and you can put a letter in, but you can do the same thing, right? And so suddenly you've immediately started doing algebra. Because and it's a really easy transition for the kids to make. I don't want to see that. There's a really easy transition for the kids to make because all you're doing is replacing the starting thing with a G or an X or whatever letter you want them to pick. It's really up to you. And then you just do the same thing. And suddenly they're building up nice algebraic equations. And you can do these lessons in exactly the same way. Hopefully they'll pick it up a bit faster than they did the previous thing because it is the previous thing, just with the letters to start with. But again, give them lots of practice of that. There's lots of practice in here for them to do. And again, building up these expressions, noticing that things just repeat over and over again. You just build up the expressions. What you want them to say as they're telling you these answers is, when you get to number 4 and you call someone to do it, they'll just say, oh, what we wrote before plus 2. Like, that's what you want them to say, not 2G. You want them to notice that they're just writing the thing that they did before over and over again. Okay, the next thing that I went on to, and again, this is just what I did, was some expanding and factorizing. You can do this at any time you want, really, but you can point out to them that, of course, if you start with an X, say here, and you want to get to maybe this one here, there are 2 easy ways of doing that, right? You either add 2 and then times it by 2, which looks like this, or you times it by 2 straight away, and then you add 4, because you're in the 2 times table, so it's add 2, add 4. And then you notice that these 2 things look the same. By the way, you do also have to teach, when you get to the letters, I forgot to mention this, but when you do the letters lesson, just show them that x times by a number straight down is just x, 3x, 4x, and 5x, and so on, as opposed to when it's brackets, which is when you already have a more complicated expression, then it starts opening brackets. When you only have an x, you can just be lazy and write 2x, 3x, 4x. Just point that out to them. That's the only change that you have to make in this lesson here, is just pointing out that when you multiply it by a number straight away, I don't know whether I've got an example of it. I mean, I just showed you, didn't I? You just times it by a number that looks like this. Anyway, for this next section, expanding and factorizing, you just point out that these 2 boxes, because they're in the same place, bring this back to the numbers we were looking at straight away. This box must represent a number, right? It just must be a value, whatever it is, we don't know what it is. But these 2 expressions must be the same then, if they're in the same box. So you can write down 2x plus 4 equals 2 brackets x plus 2. And you can do a bunch of examples of that with them. You can go both ways. You can go this way, or this way first. It doesn't really matter. And what's quite nice about it is that expanding and factorizing kind of is the same thing to them, right? Because they're thinking of it in grid, they're thinking here. Because you've done so much grid at this point, I mean, we're like a week, well over a week of doing this, I think, by now, with any class. They would think of this as moving 2 to the right and then 1 down. So they'll think, okay, otherwise I could go 1 down and then just 1 to the right, and then 2 to the right again, and they'd come up with 2x plus 4, right? They think about this through the grid system. And likewise this, which is factorizing, they would think about it in the same way. Here they thought, okay, you've times by 2, then taken away 6. Taking away 6 in the 2 times table is moving 2 to the left. So 2 to the left here would be x minus 2 brackets. X minus 3 brackets, and then 2. You move, 3 to the left in the 2 times table, isn't it? So it would be 2 brackets x minus 3. And they can figure that out, despite the fact that I apparently can't. They're pretty good at figuring that and seeing this as the same thing, so I quite like this activity. Although you can do more practice of expanding and factorizing in a much more simple, standard way. I threw some of these in as well, despite the fact that grid obviously can't really replicate this. It's nice to talk about them and nice to start talking about some squares and stuff. And at this point, I was trying to sort of wean them off the grid a little bit and start doing some algebra without it a little bit. Not too much, but I was trying to do some stuff outside, just show them we can do algebra without it as well. This is quite nice though as well. This is the kind of thing that you wouldn't normally do with year 7 at all. But and most teachers wouldn't think of this as expanding and factorizing, but it kind of is. Because it's just the same idea, right? It's just that you're starting with an x up here, and you're saying, okay, well, if I were to get to here, this must be the same as this, right? Those 2 expressions must be the same. And again, the higher ability year 7 groups that you teach will be able to figure this out just because they'll be thinking about their grid a lot, and they'll be thinking about what they have to do with that. So yeah, this is quite nice, and they were able to do that. So looking at stuff like that was quite good. Okay, so like I said, we were trying to maybe leave the grid a little bit at this point. So I started giving them things that look like this, and saying, okay, well, we know what moving one to the right in grid algebra looks like, but that's just adding one, so this is just x plus one, and this is then 2 brackets x plus one. And all of my classes that I taught this with, the highest and the lowest ability or attainment, were doing really well with this. Like they picked this up really quickly. I gave them an example, and they could fill in things like this very happily. So I was glad that we were sort of happy to leave the grid and just do this without it, which was nice, because that's of course the whole point. So yeah, we practiced lots of this. The next phase that I went into was, okay, so instead of giving you a root, so basically, I know I just did a lot of expanding and factorizing and other stuff, but basically the last thing that we did, with the grid was we looked at a root like this, and I was like, give me the, where's number 5? That's kind of where we looked, right? We went here, 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 and we built the expression up. That was kind of the last major thing that we did with the grid. And what I'm going to do this lesson instead is I said, okay, well, if I just gave you this, and then if I pause I freeze the screen at this point, and I just did some dragging like this, and then I got to here, and then I deleted all of these, and what I asked them was, could you draw the arrow that you would have otherwise been following to get you to here? So okay, they look at this and they think, okay, look at the target, it's 4x, so I must be going here first. And then it's plus 8. We're in the 4 times table, so that must be to there. Then it's divided by 4, which means just going back up to here. And they get quite good at this, right? They get quite good at drawing the arrows. You can print out a bunch of sheets if you want to, and you can hand it to them, and you can get them to draw all of the arrows in. So for example, their target is here. You draw the arrows so that they get to the box that contains this, or you do it with the target in the box itself, like I was describing, and they draw the arrow in. Obviously, these ones are more difficult with some much more bigger expressions. Either way, or of course, you literally just do it old school, and you give them something like this, which relates nicely to what we just finished doing, which was these kind of ones. They do it backwards, essentially. They fill in all the operations and they fill in the missing things so that we smoothly get from one to the other. Or you could just do it, so this is the highest attainment group that I was doing it with. We just did this. I got them to write out this, and we just said 1 dot minus 2, 2 dot times by 3. We just wrote the operations out in order, a bit like this, but much more complicated, obviously, for this. So 1 dot take away 2, 2 dot times 3, 3 dot plus that, 12, 4 dot divided by 3, and so on. And I just got them to write down all the operations here. And I tried again to transition towards doing non-grid algebra things here. There's some nice algebra here that you just take away a. They pick that up quite easily. BidMass, which they've done in primary school, told them to square first and then times by 4. So a lot of them picked that up, though of course a lot of them needed to ask me, which is fine. But yeah, writing in these orders of operations, and whichever task you do here, and you could do any of them, the idea behind this is if they can do this successfully, they can substitute. Because if they can look at an expression like, say, this, and know that you take away 3 first, then times by 2, either by drawing on the grid or just writing the things out, it means that when they put in a number, they can just do that to the number. Right, so here they can take this number 8, take away 1 first, and then times by 3, or times by 3, then add 2, and so on. So we just prepped an entire lesson just to allow us to then substitute, and you can break out whatever substituting worksheets you want at this point. Apologies, I don't know where I got these sheets from, so I probably shouldn't have included them. But anyway, or you can use the sheets that I've drawn here. This is again for the highest ability group. This was the first substituting lesson that my 7 set 1s ever saw, and it's, as you can see, quite complicated. I really like these kind of tasks here where they have to write their own questions. This is obviously a tangent completely, but I really like getting kids to write their own questions because I think it allows them to think about it from a much better point of view. I think is, or not much better, but a different point of view that is interesting and is important, I think. For example, how do you write a question where the answer is 14, right? Or how complicated a question can you ask? Yeah, it makes them work it out backwards. It's good. I just like adding things like this on the end. Anyway, that's complete tangent. Anyway, so yeah, substituting numbers in. So that's that thing done, which is good. At this point, I did some more normal substitution. I tried to cover the substituting that grid couldn't do, like this, and with double inputs and things like that. And then I just gave them a bunch of normal substituting worksheets that you find online or could make yourself with lots of inputs and different things. And again, spend a couple of lessons doing that along with your grid algebra substitution as well. And then, okay, so we're now at the last bit, phase number 9 and 10, the last bit, which is solving equations. So when you go back to our grid, we say, okay, well, we did a root, and then we figured out a root. If I deleted everything, we figured out what the root was. Last step, you do a bunch of dragging with a freeze screen, and then you delete everything, including this, and you ask them, where did X start? Right, you just shove this on the screen and say, where did X start? Of course, you don't have to pick as a complicated one as this to start with straight away, but you could do. And they'll have to look at this and go, okay, well, the last thing that happened was the 5 brackets. So to undo this, and there's a really good button here, inverse mode, you have to divide by 5. And that gives us a slightly simpler expression. Then the last thing that happened was taking away 1. So to undo that, we have to add 1, which means going this way. And then the last thing that happened was divide by 4, so we have to times by 4. Then take away 8, so we have to it was adding 8, so we have to take away 8 to undo that, and then times by 4, we have to divide by 4 to undo that, and we end up with our starting button here. And again, you can cold call, you can do mini whiteboards, you can ask them, which box was the starting X in, and they can work backwards. You can get them to draw the arrows, so there's lots of different worksheets you can make them do here. What I got them to do with my highest ability class was we just wrote the expression at the top, we did action here, sort of undoing action we called it, and then new expression. So the undoing action was +7, and we end up with this expression. Then the undoing action was divide by 3, and we end up with this expression. So it's exactly like building up the expressions where you're writing the same thing over and over again, but you're doing it backwards. So it's exactly like that. Otherwise, you could get them to draw in the arrows to get to their original point. You could get them to do that as well. And this is a worksheet that I just gave mine to do. They wrote the expression at the top, exactly like the example. They wrote the expression at the top, then they did their undoing action on the left, and then new expression on the right, until they got all the way down to X, or whatever letter it is that is in the question, obviously. So okay, that's quite cool. And then phase 10, of course, last step is you tell them what an equation is, and then you do it exactly like this, or this is how I did it, I should say. You have the undoing action next to the arrow, and then you've taught them that via this slide that you have to do the same thing to both sides of an equation. So you add 1 to the 3 to make 4, because you're adding 1 to undo this, and then you undo that by dividing by 2, which means and so on, right? And now you've got balancing method. And again, for my 7 set 1s, this was the first ever solving equations worksheet they saw, which looks horrendously complicated for year 7, but they actually did this like they thought this was pretty straightforward, to be honest. Like all of them were doing this very, very well and very confidently, because they've done, this is like 3 or 4 weeks in now, they have done so much of building these expressions that they're just very comfortable with doing it backwards, because they're just very comfortable doing it forwards. And so again, that's what I gave them 2 worksheets that look like this, and that's kind of and yeah, that was where I got to. That was the end of our grid algebra session. The other thing that I do want to talk about though is I mentioned before that grid algebra have resources that you can use. They also have this tab, which is tasks, which I didn't use a huge amount, except for when I missed a week because I tested positive for COVID. And this was a really good thing that I did when I was ill, because I wasn't really ill, I was just COVID positive, so I was sending in cover work. And one thing that I got them to do was just walk down to the computer room, and they just had to do some of these tasks. If you've got Chromebooks or laptops that you can use, or anything else, or of course IT rooms that you can go to, these are great. These tasks, they're so amazing. They save you a lot of work, because you don't have to print out all these worksheets for them to do, but also they can do it much faster. Because, for example, one that I quite liked was this one here. I think I remember quite liking. Yeah, you just have to draw an arrow to get yourself from here to here. So we look at this, the first thing is having double, to go from b times double to 6 times double, then we add 6, right? And we say finished. And you can just wipe out so many of these so quickly. So the first thing that happened was you divided by 2, so that gets you to there, then you take away 6. And the disadvantage here, of course, is, well, actually no, because it's being marked. The disadvantage is they might mess around because they're on a computer, but hopefully, try again. That's nice, isn't it? So I should have noticed +4 first is there, then divide by 2. But I'm dumb, so I didn't notice that. But again, you get instant feedback as you're walking around the room. You could see how many of them they messed up and got second time or third time, whatever. So this is doubling, then taking away 3. So I believe that, no, it's not. It's taking away 3 and then doubling. I'm really tired and I'm trying to concentrate on what I'm saying. I'm going to use that as an excuse. But yeah, this is really great. They get instant feedback. They can do it really quickly. They can do loads of them. Like I said, I was tested positive for COVID. I just gave them a couple of these different tasks to do as cover during the lesson. I don't really have any evidence for how well they did because it doesn't send me anything or any data or anything like that. I did once set this as a homework. Again, the disadvantage of that is that there's no evidence that they've done it that you can see really very easily. I'm fortunate enough to work at a school that I just trust that they have spent half an hour doing it. And also, you can just tell them to do it because it's fun, right? Like, I only set this as a homework once, but I did say a few times, you can just go home and you can do this in your own time. Because a lot of it, they'll just find quite fun, right? Like, I haven't actually, this is a risk. Okay, so you got 5 seconds to get from A to A plus 1. Just to click where B would have been. Right, so they can challenge themselves, see how quickly they can get this. So, okay, so the first thing is it there? Excellent. So yeah, they can do loads of these. It's so great. It's amazing. Grid algebra is great. I hope that I have summarized that well. I think I had a slide here that was like summarized everything. Was it here? Yeah, it teaches order operations. It teaches constructing equations, which allows for substituting and solving super well. Like my year 7s were solving these equations, which not many year 7s can solve, right? So it's so good at teaching that. The disadvantage is that it doesn't have squares. It doesn't have multiple operations. So when you get to like 3x plus 4 equals 10x minus 7, you have to teach a little bit more about that. It doesn't do any collecting like terms at all. So you have to find your own space or time to do that, but I haven't found a way for it to really help you out teaching that. And likewise, it doesn't help you solving equations like this very much. But once you have a feeling for equations like this, hopefully then teaching this on its own is not too bad. They'll pick it up, hopefully. At least I think that should be the idea. So anyway, I think this is really great. If you are a teacher and you've watched this and you have more questions, you feel free to email me. Because I'd be more than willing to talk about it some more. I think it's really good. Again, thank you to these people who I would not have been able to do most of this without. Yeah, I hope you enjoyed this and I hope it was informative. I definitely suggest that next time you have a year 7 class and you're teaching algebra, that you just go ahead and try this. It's really great. It works with all abilities, I think, though you obviously go at a different pace with different groups, but I just think it's really good, so you should definitely try it.